Now let's go to adding more layers to neural network. Okay, last time we learned about single neuron. Now we're moving to more neuron on more layer. Okay, when you said more layer, definitely will need more neuron, so we're gonna say multi-layer term. Alright, so what you got now is basically is two neuron there. So the same, you got all neuron, the same structure arrangement like the previous slide. Okay, you got activation function, summation, y is equal to wx plus b, so on, and this is the activation function. Now basically you got input x1 and x2 basically. Alright, let's say this input is based on you got feature x1 and x2. Okay, and here is a label. Okay, so this is there as usual, the way you learned last time. Okay, now what's happened next is basically you just put 1 2 3 4. You got 1 2 3 4 path. So basically 2 times 2, you got 4, and at the same time you have w1 w2 w2 3 and 4, so you got 4 weight there. And then later you got summation product, and then each node we're gonna be having bias, and this bias. Okay, remember each node gonna have one bias, so every input will go to every layer path, and every path has weights. Okay, and w1 2 and 4 are weights. Every path has weight, so every this one has weight. So you got 2 times 2 4, you got 4 path, then you got 4 weights. b1 2 has bias, so every node has one bias. Every node must have one bias. Every node must have one activation function. So this is sigmoid, you know, 1 over things. We'll see later. Alright, so let's look on more layer like this basically. So we got here basically 1 2 and 3 layer. So 3 layers of neural network, and each has 2 3 and 2 neuron. So in this case you're gonna have let's say we have 2 inputs, so this one and this one. So model has 2 hidden layer 1 and layer 2. Layer 1 has 2 nodes. Okay, layer 2 has 3 nodes, 1 2 3, and layer output also 2 label, so mean 2 nodes. Layer output has 2 label. Alright, now so every input has path to every node. Every input here has a path to every node there. So you got 2 times 2 4, 1 2 3 4. So this is 2 times 3 6, 1 2 3 4 5 6. So the last one is 3 times 2 6. You got path 1 2 3 4 5 6. Every path has weight. So look at that. See, you got 4 path, then you got 4 weights. So here you got 6, 2 times 3 6 path, you got 6 weight. Here as well you got 1 2 3 4 6, so you got 6 weight, and value are different. So the random value here are different to each other. They are not value w1 and w2 w3, and all are not the same value. They are assigned to random numbers. So every node has different bias. So you got one bias here, one bias for this node, one bias for this node. So until 5. So you got 1 2 3 4 5 nodes, so you got 1 2 3 4 5 bias. So output no bias. Okay, every node has the same activation function. So this activation function with this and this are the same. Okay, and this is for the output used differently and are the same. Okay, every node has different output. So since you got different weight, so you got different output. So this one come here to move this one and this one. Okay, so the output gonna same, but you're gonna have different from each one. The node has different output fs. The node has to do summation s. So s here basically. Alright, so in this case you got many, so basically s equal to w1 x1 plus w3 plus x2. Okay, then you're gonna plus b1. Okay, remember this, wx1 x1 w1 x1, okay, plus w3 x2 w3 x2. So this and this. Okay, then you got another one is s equal to w2 x1 plus w4 x2 plus b2. Okay, so this one basically goes to this. Okay, for this one. Okay, so this one and this one are basically for this one. Alright, and so on. Okay, I think this one follow the similar thing. So you got w5 minus fs. Okay, plus, so we got x6 and this one. So you have w6 minus fs here. Alright, you got plus b3. This is b3, this is b3, and put it there. So basically this one w5 fs plus w6 fs w6, this one. Okay, and plus b, then you got this one. So for this one, so you got w7 here, w7 f. So this is this one fs, this one, plus this node. Okay, you're gonna have take this one w8. So w8 fs. Okay, take that one, the first node, and then you're gonna plus, because this one you're gonna take this one. Okay, w8 and fs is this one. So you're gonna plus b4. Okay, so these are for this, and this are for this. Okay, you got it? Run. Okay, move to the next slide. So this is the activation function. Basically what you see here is consider sigmoid basically. So this one basically what you call sigmoid. S come out from the node determined by final value fs come out from the nodes determined by activation function. In the example we use sigmoid. Okay, so what you see so far is this is sigmoid basically, function of sigmoid. Okay, what does it mean, sigmoid function? So if you look at this graph, whatever s from negative value to positive, the output fs always within 0 and this value. Okay, whatever the value s, either positive value or negative along the line here, whatever the value, the result always be positive between 0 and some value here. You see the graph here. Okay, so which means that whatever the s, you're gonna make it positive. Remember, so all the negative will become to positive, and all the positive will be still positive, but we have a maximum value here. As it increase, the value still remain the same. It doesn't matter how much increase. So basically it's shaping how the final output gonna be. Okay, it's not really you take as it is what being calculated here, but actually it depends on the activation function. Okay, so this is sigmoid function. You're gonna others as well is ReLU. This is one you heard. So remember this one and this one different. So it's basically any negative value of s, the fs will be set to 0, and all positive value from s gonna be set as it is. Okay, this one as it is. So this is ReLU, and leaky ReLU basically just a little bit down there. Alright, so remember here fs, and here. Okay, so it depends on this one. So this is sigmoid. If you use ReLU, you make this one. So the output basically fs and fs here is different based on what formula you have here. So that's called activation function. They activate the input in some certain way. We move to the next slide, feed forward. So the feed forward basically is follow the previous slide where we got x1 and x2 as the input. So basically is you got the same thing like this, where here is x1, x2, and this is label here. Okay, so basically feed forward just go all one direction one time. So basically you got at the end of the day you got loss and target value. So target value basically just now you got this one. Okay, so label basically is go there for the target value. Okay, so basically loss will be defined by target value minus f. So this is again f. Okay, and this target value basically is input from there, label. Alright, so basically what's happening here is you're gonna this there, and then this go there, this go there, and then is move here, then move here, then move here, then move here. So everything here all together, s and f, then you got f is here, target value. You can get the loss. Okay, you can get a loss. Okay, move. Next, back propagation. One you get loss, one you get loss here just now. So basically you have to return back to change, minimize the loss, to change the value of weights and bias. In order to change the weight and bias, basically what you need is optimizer. Optimizer, basically it is a function, okay, just to make a loss to perform the back propagation, changing the value, weight and bias. Function there to change the value, weight and so we go backward in effort to minimize the loss. Optimizer is a function to change the weight and bias, okay. And so basically based on the function, and they're gonna change this value W3, W2 and W1, either increase or decrease. You're gonna have a learning rate, basically learning rate, okay. If learning rate is bigger, basically the decrement or decrement will be bigger. If learning rate is small, basically is 0.05, okay. So this is considered small, so the increment is small. Basically the increment, you got a function there, so you got there, if you change a new value, he gonna be changed like that until at the end of the day he gonna add this thing, okay. So he gonna change based on learning rate when moving backward. So optimizer, you has a lot of optimizer you can choose. Gradient descent optimizer, okay, ada delta momentum Adam optimizer. So basically you're gonna use this and this, okay. Gradient descent, okay. Gradient descent basically is you got dy dx here with value here. When you change W and bias and weight, you're gonna have like this, and then you're gonna dy dx again until gradient. So the descent will be in gradient until the end of the day you're gonna find this. So mean it is loss is 0, basically here loss is equal to 0, okay. And so learning rate basically is simply change the value according to the learning rate. If learning rate is bigger, then the change value of W, W2, W1 is a little bit bigger. If learning rate is smaller, then the change of W, either decrease or the increment, will be smaller. So when you're moving forward, they're gonna have reduce the loss. So here we can define learning rate is as optimizer update weight and bias towards 0 loss. Learning rate is the rate of optimizer change weight and bias, okay, either small or big. Alright, and so what's down here basically is a rule that optimizer has to follow to change W and B, okay, a learning rate, okay. So epoch, as I told you, one epoch consists of one forward and direction, and then backward direction, and then go backward direction, where optimizer is executed, and for all sample in dataset. So one forward, then move backward. When move backward, you're gonna use the optimizer to change the value of weight and bias according to the learning rate, how much the increment and decrement of weight and bias. Then, and it happen to all dataset in sample in dataset. If you got 10, mean basically you have to go forward and backward 10 times according to the total of dataset. Once all dataset been forward and backward at least once, and value W and bias change, so it is called one epoch, okay. So one epoch is when entire dataset is passed forward and backwards once through the network, okay. So basically if you got 100 sample in a dataset, so this 100 must be go forward, got the loss. When you got loss, you move backward using the optimizer and according to the learning rate to change the value W, and bias. So this is 100 time happen 100 time because 100 sample. Now the batch basically is a training example present in the single batch. So if you got 100, let's say you got 5 batch, okay. So basically 5 batch mean one batch is equal to 20 sample. So in order to got one epoch, basically have to go 5 batch. For 5 batch, 5 times 20 equal to 100. Okay, there's a batch. So in this case, you got one batch is 5 batch, one batch is 20, so that's mean you got 5 batch. Okay. And iteration basically is a number of batches needed to complete one epoch. So in this case, you got 5 batch, and each batch is 20, then mean you have to do 5 iteration in order to complete one epoch. Okay, this is straightforward. Alright, the number of batch is equal to number of iteration in one epoch. Yes. So you got 100. You got one batch is 20. So that's mean you got 5 batch. 5 batch mean 5 iteration. Okay. Alright, and so this is example of a batch, epoch, batch, and iteration. Let's say we have a 2000 training example, and we're gonna use 20,000 total of sample in a data set. So we can divide the data set 2000 example into 500. So that's mean we got 4 batch. When we got 4 batch, mean we got 4 iteration, and which is simply one epoch. Okay, so batch size is 500 and iteration is 4, or batch size is 4, batch number is 4. Then is you can have one complete epoch. Okay, by 4 iteration you got one epoch. Okay, because 4 times 500 equal to 2000. Okay, so this protocol also called mini batch gradient descent. So if you heard the term mini batch gradient descent, basically this is okay. You got 4 batch, mini batch, where these 4 batches is going 4 iteration to complete 2000 example in one epoch. Okay, and so this is some example of loop. Okay, you got 100 sample here. Let's say you got epoch 40. So basically when you got 40, basically is 40, you're gonna 40 times 100. So it's equal to 4000. Okay, 4000 sample gonna be forward and backward. So number of batch is 5 iteration, mean that one batch consists of 20. Okay, so it's just go for I less than equal to epoch. Epoch is 40, so you're gonna repeat it 40 times and do, and then from there you can compute a loss and optimize the batch size. Okay, and so this is what happened during epoch. You're gonna keep during if let's say it is 4, then that's mean you got 4 times in one sample until at the end of the day you got here. You're gonna change during the optimizer and learning rate. Okay, until got 0 loss or 0 error. Parameter and hyperparameter. So parameter is defined basically is any value that changed by computer. There are weight and bias. So these two are called parameter. Okay, hyperparameter at the other hand is any value that changed by human. So this is changed by computer. So weight and bias normally changed by optimizer. According to the learning rate, you're gonna automatically change the weight and bias. So this is called parameter. Hyperparameter is human, changed by human. We change the value. What we change, we set the learning rate. we set the epoch, how many epoch we want to do. We set the batch, how many iteration, number of layer, 2 layer, 3 layer, 4 layer, up to us, and number of node. And how many nodes in each layer is up to you, 1000, 1000, and so on. And drop out, we'll learn this later. Okay, so this is the difference between parameter and hyperparameter. I think that's for today. We're going to continue on tutorial later. Thank you.